Hello and welcome to Excellent Link Academy. For this class, we'll look at the concept of mole under chemistry. So let's discuss mole and its mathematical expression, and then we'll solve several past questions using the idea or the concept of mole. Let's discuss mole a bit. By definition, a mole of a substance is the amount containing as many elementary entity as the number of atoms in exactly 12 grams of carbon 12. That's like definition of mole, right? A mole of a substance is the amount containing as many elementary entity as the number of atoms in exactly 12 grams of carbon 12. Usually, the short form of writing mole is given as MOL. This is simply the short form of writing mole. MOL is simply the abbreviation or perhaps the symbolic representation of writing mole, as you can see. All right. Usually, mathematically from here, we said mole, MOL, is equal to mass all over molar mass. Molar mass. This becomes your mathematical formula for calculating mole. So note that mole is equal to mass all over what? Molar mass. Usually, mass is in gram. Molar mass is in gram per mole. Gram per mole. MOL. So this is the symbol, the SI unit for mass, SI unit for molar mass. So we have done a video. I've done a videos that explain the concept of molar mass. Either you call it molar mass or relative molecular mass of a compound, if you want to. So this is your mathematical expression for calculating what? Mole. Right? That's your formula for calculating mole. At this point now, note something, please. At this point, note that an atom of carbon 12 weight weighs 1.99 times 10 to power minus 23. So note that an atom of carbon 12 weighs 1.99 times 10 to power minus 23. What does this implies? This implies that the number of carbon atom in 12 grams is equal to mole. So I'm saying that this implies that the number of carbon atom in 12 grams is equal to the mole. What do I mean? From this concept, I can say that one mole is equal to mass. We said is 12 gram, Abi. 12 gram, right? 12. Another of carbon 12 weighs. So 12 is the mass. 12 all over this is the weight here, right? I have 1.99 times 10 to power minus 23. So if I'm to punch this value, I'll have a value given as 6.023 times 10 to power what? 23. This value I just get, right, from this concept, this value I just get is called a constant. This value is called a constant known as 6.023 times 10 to power 23 is called the Avogadro's constant. This value is called Avogadro's constant. So note that 6.023 times 10 to the power 23 is called Avogadro's constant. So in expressing mole in terms of Avogadro's constant, what do we get? So neutrally, we know that mole is equal to mass all over molar mass, right? Which is equal to number of particles all over Avogadro's constant. Number, or if you want to, either I call it Avogadro's constant or Avogadro's number. So in expressing mole in terms of Avogadro's constant, I'll have this formula. So note that aside mole being equal to mass over molar mass, it can still be expressed as what? Number of particles over Avogadro's constant. So this becomes your mathematical formula for calculating mole, right? So note that number of particle, note that the number of particle here, that is number of particle that we're talking about, can either be atom, the particle can be atom, ion, right, electron, proton, neutron, and then etc. So note that when it comes to number of particles, the particle can either be an atom, ion, electron, proton, or neutron. So note that number of particle concept represents all this stuff. So this is like all like you need to note for the introduction to mole concept. So now let's now use all this idea now to solve some problems under mole concept. Example 1 says, how many atoms are contained in 1 mole of hydrogen molecule? Listen up. It says, how many atoms are contained? Example 1. Example 1. The one says, how many atoms are contained, right? So obviously, okay, are contained in 1 mole. In this case here, number 1, let us given. What am I given? Givens. What am I given? Number 1, I'm given mole. How many mole am I given? Just 1 mole. I'm given 1 mole. It says that how many atoms are contained in 1 mole of hydrogen molecule. Usually, I'm also given what? Hydrogen molecule. If I have just H, H here if I have just H signifies just hydrogen. If I say hydrogen molecule, it means what? Diatomic, 2 of it. So this is what? This hydrogen molecule, as you can see, it says how many atoms. So here's the thing, to solve this problem is quite easy. Your very first task is to recall your mole formula. So recall that what we know is that mole is equal to mass over molar mass, which is equal to number of particles all over Avogadro's number, right? So I have this, right? This is what I know neutrally. See this equation. This is my first equation. This one is my second equation. This is my third equation, right? Now here's the thing. In this given here, I'm given mole. So I can see mole here. I can't see mole here. So I'm using this first equation. This first equation, I'm using it. Now when it comes to mole concept, here's the technique you use. Here's the guess. In every question they'll give you another mole. You'll be asked to find only 2 things, right? You've given, like now I'm having 3 equations, right? So in this 3 equations, you just pick 2 out of the 3. That's the concept. You always pick 2 out of 3. You can't use the 3 at the same time. You pick 2 out of the 3. So what you are given depends on what you pick. In this case here, I'm giving mole as 1. So I'm picking this part, this first equation. I'm having 2 and 3 left. Which one am I picking? It says that how many atoms? So that's what? Number of particles. We have said number of particles can either be atom, ion, electron, and proton or neutron. So in that case, I mean how many atoms? So I'm looking for what? Number of particles. Which is atom here. So I'm picking what? Equation what? Equation 3. I'm not given mass in this thing. I can't use it. Although I can find the molar mass of H2. But yet I can still use this equation. So I'm not using what? The second expression here. So for this question now, I'm using just mole equal to number of particle. The particle we're talking about here is what? Atom. Number of atom all over Avogadro's constant or Avogadro's number, which is what? 6.02 times 10 to the power 23. I have this. In this case here, put in your value. What's mole? Mole is 1. So I have 1 equal to number of particle is what we're looking for. So that's which is atom. So number of atom all over Avogadro's constant. That's 6.02 times 10 to the power 23. To get this value, I'll simply do a what? Cross multiply. So I'll have number of atom will be equal to 1 times this. So I have 1 times 6.02 times 10 to the power 23. This will give 6.02 times 10 to the power 23 atom. Right? So it says how many atoms are contained in 1 mole of hydrogen molecule. That's what? 6.02 times 10 to the power 23 atoms, right, are contained in hydrogen molecule. So that's how you solve this particular problem. Let's do yet example 2 under this. Let's do example 2 under the concept of mole. Example 2 says that how many protons are there in 6 grams of carbon? How many protons are there in 6 grams of carbon? All right, let's get this done, please. First, we said first, write out your givens. What are you giving the question? It says that how many protons are there in 6 grams? That 6 there, 6 grams is mass. Because said mass is measured in gram. So I'm giving gram, I'm giving mass, that is M as what? 6 grams. What next there? How many protons are there in 6 grams of carbon? So the element there given is what? Is carbon, right? So let's get this done, please. Before I can solve this, first, write out your normal equation of mole. So recall that we said that mole is equal to mass all over molar mass equal to number of particle over Avogadro's number, which is what? 6.02 times 10 to the power what? 23. All right, in this case here, are we given mole? So I'm having my first equation, second equation, and third equation. Which two equations best suit this solving of this problem? I'm given mass, so it means that mass exists here. I'm using equation 2. In between 1 and 3, which am I using? The question says that how many proton under what? Number of particle proton. So I'm using what? Equation 3. It means that I will eliminate what? Equation 1 is not. This one is not there now in this case. So I'm going with equation 2 and equation 3. To solve this now, it's quite easy. From there, I'm using just 2 and 3. So I'll have mass all over molar mass, which is equal to number of particle, which is number of atom in this case. Or perhaps start given there, is it atom or proton? In this case was proton. Number, how many protons? So it's proton. That becomes number of proton all over Avogadro's constant. That's 6.02 times 10 to the power what? 23 as given value there. It's easy now. What's your mass? The mass given there is what? Is 6 gram. So I plug in 6 gram there. So here becomes what? A 6 all over molar mass. The compound or the element given here is carbon. Carbon is just an element, not a compound, right? And I've showed you how to calculate the relative molecular mass of a compound, or perhaps the molar mass of a compound, right? In this case now, this carbon now is not a compound, just an element. So here's the meaning, here's the concept. The molar mass of just an element is equal to the mass number of that element. What's the mass number of carbon? That's 12. So in this case now, my molar mass becomes just 12 equal to number of proton is what we are looking for. So I have number of proton all over Avogadro's constant. That's 6.02 times 10 to the power 23. I have this. Next task is to multiply this 2 and this. So I'll have 12 times this. I have 12 number of proton is equal to 6 times Avogadro's constant, 6.02 times 10 to the power 23. At this junction, multiply these two. I'll have that 12 number of proton will be equal to 6 times this. I take my calculator and punch the values. At this junction, let me just make a quick solvings to save our time. I can eliminate this. We're looking for number of particles here. I will now divide here by 12. Divide here by 12. This will not cancel this. So number of proton will be equal to, if I multiply this divided by 12, I should have about 4.33 times 10 to the power 25 what? Proton. This is how you solve this problem, please. This is how you solve this particular problem, as you can see in front of you. Here's just the concept behind mole concept. Let's do yet example 3 and let's see what we get. Let's do just one more question, and then in our next class we'll solve yet other much example to further increase the in-depth understanding of mole concept. Example 3 says, how many moles are there in 20 gram of CaCO3, that's the limestone? Given that CaCO3 is equal to, I'm going that CaCO3 is equal to 100 gram per mole. So I'm already given the what's it called, the molar mass, or perhaps relative molecular mass already of this compound is 100 gram per mole. No problem. What next am I given there? It says how many moles are there in 20 gram. I'm given mass as what? 20 gram. That's all. So I'm looking for how many moles. So in this case now, I'll recall my general formula for mole concept. So recall that we know that mole is equal to mass all over molar mass, which is equal to number of particles all over Avogadro's constant. I have it here. In this case, I have equation 1, equation 2, and 3. Which one am I using here? I'm using mass, so I'm using this equation. Equation 2 is used, I'll use equation 2. And what am I giving again? Annual mass and molar mass are this. What am I asked to find? I'm asked to find that we're going to say how many moles, right? So I look for mole. So I'll be using equation 1 and 2. 1 and 2. So from there, for this question now, I'll be using just equation 1. That is, mole will be equal to mass all over molar mass. In this case, I'm looking for mole, so I'll write mole is equal to, what's the mass given? 20 over, what's the molar mass? That's 100. In this case here, mole is equal to 1 over 5, right? Which is equal to 0.2. So which is equal to what? 0.2 moles, right? Mole. So I've gotten the number of mole. I need 0.2 mole, right? So yeah, so this is 0.2 mole in CaCO3 limestone. So this is how you solve this particular problem. So next class we'll do several more examples to further explain the in-depth concepts behind mole concept. If you're interested in joining my WhatsApp group, I just created the WhatsApp group where you can actually learn from there and also share ideas from different students from different countries. If you're interested, just check the link below in the description. I drop a link to the WhatsApp group in the description, so just click the link and then you'll be joined to the group automatically. And also, if you are interested or if you want me to teach you, if you want a private class with me, you actually text me through my WhatsApp number and then you reach me out. You tell me the courses you want me to teach you and then we'll discuss. So if you found this class helpful, do it to like the video, comment, subscribe to my channel, and also share to friends and classmates so they can learn too. So see you in the next class.